In the second video, let's talk about the last two topics, file input and output, and the const keyword. In this class, a lot of time we will try to read the information from a text file, and we need to write something to the text file. So then we need to have the file input and output. From the prior courses in 110, 165, we know if we want to read file input or output, we need to include fstring library. So this fstring library including the ifstring to read from the input file and ofstring to write to an output file. Of course, you can have the fstring. This one is work with the binary file to input and output at the same time. So here is the example. If we want you to open a text file, so then we can see we want to do the read the information. So we include fstring. So usually we have the file string object to create. So here we want to read from the data.txt file. So then we create the ifstring object called thing. So here, after you create this object, you need to let it know which text file you want. So then we open the dat.txt file. Then we check if this file is good and find that. After we finish, we need to close that. So one more thing we talk about when you read your text file. In this course, we only allowed you to open a text file within the file name only. Please do not include any path. So on the other hand, according to different IDE you run, you need to know where is your working directory. So those text files, they need to save in the working directory. And this one is the input we read from the text file. So then in your, after our reading pages, actually we have the exercise, small exercise to ask you to write information to a text file. So then here, right, you still need to include the fstring library. So then we create the ofstring to declare which file you want to write to. So then you open that file. So then when you write to the file, actually they just kind of your ofstring object you create. They are just similar like cout, because fstring actually inherited from the iostring. So that's why when you want to write, you just do the fout. Then what you want to write, you write insert to the fout. So then they will write into the text file. So then here actually just a review how we will do the file input and output. So make sure you read through the reading pages and do the exercise and submit that so I can review your work and give you the comments. The next 10 minutes, I want to go over very important concept about the const keyword. The const keyword, you all heard about that. But in these courses, we will talk about even more how to use the const keyword. Right, you can think about, post this video, think about in the const keyword so far, what did you learn? Then you come with me to talk about the const keyword. Right, your const keyword, we can use the const keyword to declare a variable, right? So if you using the const keyword declare a variable, this variable become a constant variable. That means you declare this variable, right away you need to assign a value. And afterward, you cannot change the data value. That's the first time you learn the const keyword. Then after we learn the pointer, we talk about the const keyword. So then here you have a const int pointer p. So if you do so, what happened? This one actually we say this constant associate with this integer. So this const keyword actually associate with your pointer data type. Let's make this pointer P become a read-only pointer. So whatever this P point to, they are pointing to a constant integer variable. So then they make the data they try to access as a constant integer. So on the other hand, they are read-only. Through the P, you only can read that value, but you cannot modify the value. So this const keyword actually is what I want to go over to the next. I want to show you this const keyword when we associate with pointer. Actually, we have 4 different ways to associate with pointer. So that's we talk about the principle of the least privilege. That's very important in C++. We always try to give a function enough access to the data in its parameter to accomplish a specific task, but no more. In C++, actually, we can use the const keyword to control how much access we want to allow a variable or a pointer to access. And also the const keyword, remember, we also can pass the parameter by const through the function. So then they become a read-only. And also the const keyword, we also, if we want to write a member function in a class, we can add the trailing const to make this function become a getter function. So that's the const keyword, very important to accomplish the principle of least privilege. If I don't allow user to read, or I don't allow user to update the data, I put a const keyword. So they can access the data, but they cannot update the data. So from here, if we're using the const keyword with pointer, we have 4 different things. So that's the 4 different things we do. So this one actually is later. I want you to also take time when you're doing your lab exercise with your peer. I also want you guys to talk about the const keyword, how to use. Of course, in this video, I will talk about that. So actually, we have 4 different ways to using the const keyword through the pointer. So this one is the first one. You see here is the first time when we talk about the pointer, right? You have data type. Then you add the pointer. So sometimes, right? So sometimes we have the space. So that means you have the integer pointer count PTR. So through this count PTR, we can access the memory location to read as an int. And also through this count PTR, I can update an int new value to overwrite that memory location you refer to. So this one is we call it a non-constant pointer, refer to a non-constant data. Then the second one is earlier our example. We have a non-constant pointer to a constant data. So they make that become a read-only. What's that mean? That means you see, through this pointer, I always access a constant integer. So that means through this pointer count PTR, I can read this through the memory location as a constant integer. But through the count PTR, I cannot update that. Okay? If you are okay with that, so now how about the third one? What does the third one mean? The third one you can see actually is you have the int pointer, right? But you have the const keyword actually is associated with this pointer. So that's why we call this one is the count PTR actually is the constant pointer. Point to a non-constant data because you see the int is not a constant. So on the other hand, we just say here, because the count PTR refer to an integer value is not constant, right? So right, through the count PTR pointer, I can update the memory location, the data, integer, I can update that integer value, and also I can read that integer value. Then what this const mean? So actually this const actually associate this pointer. That means this pointer I cannot reassign the memory location. So that's the constant pointer. So then we have the last one is the constant pointer to a constant data. So you can see here you will have two constant keyword. The first constant keyword they associate the data type. Then the second constant keyword associated with the pointer. So this pointer will refer to a constant data for the read-only data. And also this pointer cannot change the memory location they refer to. Are you okay with that? Or you're a little confused? No matter you are confused or you're okay with those const keyword we use to do the pointer, the next page is actually is I show you everything on what we have earlier. So then you can see I have a non-constant pointer to the non-constant data. So then you see I have, if I say I have a x and a y, that's the integer variable I assign. So then you can see your pointer I refer to the x variable location. So then through the count ptr, I can update the data. I can reassign. Okay, so then the second one you can see is a non-constant pointer to a constant data. So again, x and y actually is the integer variable. So that's why I assign the count ptr refer to the x variable location. But through the count ptr, I cannot dereference to reassign the data value, the int value. But I can reassign the count ptr the location. So then the third example, a constant pointer to a non-constant data. That means I have the const keyword associated with the count ptr. So then when I declare that I have to right away assign the location, that's the x variable location. So afterward, I can through the count ptr to reassign the value to 7. But since the count ptr is a constant pointer, so I cannot reassign this count ptr pointer to another location. That's what we mean the constant pointer. So then you can see, of course, the last one, the number 4, is the small is the privilege, access privilege. So that's why you have the constant pointer to a constant data. Through the pointer, I cannot reassign the data value. Through the pointer location cannot be reassigned. So that's the constant keyword with the pointer. If you still are confused, I want you to take the chance when we do the breakout room for the lab exercise. You also have the chance to talk to your classmates. Before we finish this video, so the last const keyword example actually we will use a lot in this class is when we try to pass an object. So when you pass in the object through the function, if you don't want the object information, the content being changed, so we can using the const reference. So you add the const keyword for the object reference. So then through the s, they cannot update the data member value for the object. So they make this object become the read only. So that's our second video for the module 1.